recall, we are on session 2 of a series that I've called Answering Gospticals. Everyone say gosptical. It's not easy. At home, what I do is I stand in front of the mirror and I just practice saying the word gosptical so I don't screw up in front of all of you. So last week, we looked at the question, is the Bible full of contradictions? And if you're interested in that teaching, if you missed it, if I went too fast, it's on YouTube. So you can just Google, is the Bible full of contradictions? Put Tim Barnett and it'll pop up there. The next gospel we're going to look at is science. Wherever I go, teaching, speaking, the most common questions that I get have to do with the intersection between science and faith. Questions like this: has science made miracles impossible? Is there any scientific proof for God? Is faith in God just a blind leap in the dark? Can a Christian even be a scientist? And what about evolution? What about the age of the earth? And on and on and on it goes. Some atheists see no compatibility between science and faith. For example, last September, Dr. Lawrence Krauss, he's an astrophysicist. He wrote an article in the New Yorker, and this was the title. You can actually see the article on the screen. All scientists should be militant atheists. All scientists should be militant atheists. This kind of thing is characteristic of atheists and skeptics and what they believe. And here's what he wrote in his article, and I've highlighted some of it for you. He says, this commitment to open questioning is deeply tied to the fact that science is an atheistic enterprise. He goes on to say, it's ironic, really, that so many people are fixated on the relationship between science and religion. Basically, there isn't one. And finally, he goes on in the article to say, it's inevitable that it, speaking of science, draws people away from religion. And by religion, he's speaking about belief in God. Belief in God. And so it's no surprise that many people find science as a gosptical, an obstacle of the gospel. In fact, last night, I went to a stranger's house from 7:30 until 10 o'clock. It sounds really creepy when I put it that way. I was invited to a person's house to speak to their grade 12 student who essentially no longer believes in God, was raised in the church, no longer believes in God. I met the person for the first time, and the majority of the time we spent talking about science and faith. In fact, he wanted to invite his biology teacher, his evolution teacher, so that we could chat. It's very interesting because over the course of our discussion, we started talking about science and faith. Then he moved on to talking about, well, what about the Old Testament God? What about Israelites being commanded to commit, genocide in the Old Testament? We're going to look at that, by the way, in a couple weeks. We talked about the reliability of the Bible. These kinds of things are gospel. So science is, we're going to look at the exclusivity of Christ and hell. We looked at the Bible. Evolution is a gospel. We're not going to spend too much time on that, but I have resources online if you're interested. We're going to look at science. In fact, in our time together, I want to show you how a proper understanding of science and faith are completely compatible. Rather than destroying faith, science should actually strengthen or embolden our faith. So let's start. Are science and faith compatible? Well, what do we mean by faith? What do we mean by faith? Over time, words have a tendency of changing their meanings. Some words have actually come to mean the exact opposite of what they used to mean. So consider the word awful. Everyone say awful. A century ago, it literally meant to be full of awe. And so testifying to an awful sunset would have been communicating reverence for such an event. But I'm sure none of the men in the room woke up this morning, turned to their wives and said, "You look awful this morning," right? It's a bad idea. It's a bad idea. Why? Because language, words can change their meaning. And now the word awful means extremely unpleasant or distasteful. Ironically, the word awful has come to mean the exact opposite of what it used to mean. Now consider the word faith. The word faith, I believe, has come to mean the exact opposite of what it used to mean. And as Exhibit A, I'd like to show you a clip from a video. How many of you have seen Miracle on 34th Street? Okay, how many of you have seen the black and white version of Miracle on 34th Street? Okay, maybe you'll remember this part of the video.
You couldn't get it because you're not Santa Claus, that's why. You're just a nice old man with whiskers, like my mother said. And I shouldn't have believed you.
I was wrong when I told you that, Susie. You must believe in Mr. Kringle and keep right on doing it. You must have faith in him.
But he didn't get me that doesn't make sense, Mommy.
Faith is believing in things when common sense tells you not to.
Huh?
That's in the original, actually. Huh? You hear what she said? Did you hear what she said? She said, faith is believing in things when common sense tells you not to. That's the definition of faith. In fact, this is the definition you'll find if you read any of the New Atheist books. But this goes back to when Mark Twain said, faith is believing what you know ain't true. Richard Dawkins, probably one of the most famous atheists alive today, in his book, The God Delusion, he says faith is persistent false belief held in the face of strong contradictory evidence. Okay? And so on this view, faith amounts to wishful thinking. Faith amounts to wishful thinking. Someone has faith when they don't have any evidence. Okay? That's when you need faith. No evidence. On the other end of the spectrum, that's where science and reason are. That's when you have lots of evidence. That leads to knowledge, okay? On this view, on this modern view of faith, science and faith are completely at odds. Agreed, okay? But is that what faith really means? Well, Dr. John Lennox, who's an Oxford mathematician, he says no. He says faith is actually a response to evidence, not rejoicing in the absence of it. Faith is responding to evidence. Biola professor and apologist Sean McDowell, he says, and I like this, faith is not belief in spite of evidence, it's belief in light of evidence. It's belief in light of evidence. So who are we going to believe? You're going to believe John Lennox and Sean McDowell, or you're going to believe Mark Twain and Richard Dawkins? Well, at this point, it might be a good idea to, flip open our Bibles and see what it says about faith. Now, I could spend 45 minutes doing this, and I've actually done that in Pastor Don's Sunday school class, but we're not going to do that today. I just want to show one passage to show that biblical faith is not what these atheists are claiming. And so, if you go to the end of the book of John, the Gospel of John, John gives us the purpose statement for why he wrote his gospel. And John tells us in no uncertain terms that he recorded what he wrote, what he recorded, so that people like you and I would read the evidence and we would believe and we would have faith. Here's what he says. Now Jesus did many other signs in the presence of his disciples, which are not written in this book. But these are written. So now he's going to tell us why he wrote his gospel. But these are written so that you may believe that Jesus is the Christ, the Son of God, and that by having faith, by believing, you may have life in his name. The whole point in John writing the Gospel of John was to provide a trustworthy eyewitness testimony so that we would know the truth and believe. Does this sound like John didn't care about evidence? No, he left a whole record of evidence for us. Does this sound like John's teaching faith is just a blind leap in the dark? Absolutely not. Absolutely not. And so here we have it. Ironically, faith has come to mean the exact opposite of what it used to mean. It's moved from trusting in light of the evidence to, wishful thinking in spite of evidence. Now, here's how I actually describe faith to students when I travel around speaking to them. I say, imagine you're staying at the edge of Niagara Falls, okay? And you're watching this magnificent waterfall, but something catches your eye. There's actually a tightrope walker walking across. His name's Charlie Blondin. And not only is he walking across on this tightrope without a harness, he's doing it while pushing a wheelbarrow full of rocks. And so you're mesmerized by this, and you watch him do it once, and then he does it again, and you're hoping, man, this guy, I hope he falls. No, you would never think that. And then 5 times, and then 10 times, and then 20 times you've seen him do it, and he notices that you're watching him, and he comes over you and says, do you have faith that I could do it again? And you say, sure, I've seen you do it 20 times in a row. And then he dumps the rocks out and says, okay, hop in. That's biblical faith. Biblical faith is active trust based on evidence. You believe based on the evidence, but stepping into the wheelbarrow would be active trust or faith. In fact, just so we're clear, faith has three components. You need all 3 or you don't have biblical faith. First, you need an object, okay? The thing that you put your faith in, that you put your trust in. If someone says they're a person of faith, you should ask them, what are you putting your faith in, okay? So there's an object, there's content. These are the details of what it means to put your faith in that thing. And then finally, you need the third component, which is the action, the act of trust. It's the commitment. And so many of you have probably been on an airplane before. You put your faith in the airplane or the pilot. That's the object, the belief that it will take you from one destination to another. But it's not until you step on the plane that you have committed your trust to it, that you have that active trust. And so on this view, science and faith actually work together. Science can help tell you when someone or something is trustworthy. Science can help you do that. And so, and then faith is where you actually put your trust in it. Okay, so those work together. Now let's switch gears and look at science. It's important that we start with how science originated. At the foundation of science lies the conviction that the universe is orderly. Without this belief, science would actually be impossible. Many historians of science and scientists have inquired as to why science arose in the West and nowhere else. Why was it stillborn in places like China and Africa? Why did it arise in the West? Well, enter C.S. Lewis. I think he makes a brilliant observation here. He says this: men became scientific because they expected law in nature. And they expected law in nature because they believed in a lawgiver. It was this monotheistic belief that led to the rise of science. Who were these original men? Who were these original men that believed in a lawgiver? It was men like, and it's really an endless list, Francis Bacon, considered probably the father of modern science, Galileo, Kepler, Pascal, Boyle, Newton, Faraday, Mendel, Pasteur, Kelvin, and James Clerk Maxwell. For these men, God was an inspiration for their science, not a hindrance of it. In fact, James Clerk Maxwell, who's arguably one of the most famous physicists that's ever walked the planet, next to maybe Einstein and Newton, he actually had a Latin inscription carved into the Cavendish Laboratory doors at Cambridge University. And it says this: Magna Opera Domini Exquisita and Omnis Voluntatis Eius. Did you guys know I was fluent in Latin? No, you can just type it into Google and it will actually translate that for you and teach you how to say it. It's actually this: great are the works of the Lord, studied by all who delighted them. He had Psalm 111 verse 2 carved into the doors. Maxwell saw no incompatibility between science and faith. But what is science? What is science? It's actually notoriously hard to define what science is, but let me draw your attention to 2 ways that science is being used, the term science. First, science is defined as a methodology. This is how scientists do science. It's the scientific method, okay? And the second is more philosophical. This refers to what conclusions are actually permissible. In this case, the conclusions must comport with naturalism. At least this is the belief. Naturalism is the idea that nature is all there is, all there was, and all there ever will be. Okay? Just nature. And so, just so I have all my cards on the table, I readily admit that most explanations most things can be explained naturally, naturalistically. We live in a material world after all, and so, but not everything can be explained naturally. Let me give you an illustration to help draw out the difference between the methodology and the philosophy. I want you to imagine that a well-known person like Mike Howe is murdered in this room. Dead. I know. Who would do that? Who would do that? And so Mike's dead, and so obviously the chief of police shows up, and forensic scientists, and everybody's here. They want to find out who murdered Mike. Well, the chief of police says this to his forensic detectives: this case is your top priority. Okay, I want you to use your best forensic methodology to find the killer. So they get out their gloves and their test tubes and their swabs and all this stuff. They're ready to do their CSI thing. And then he says, oh, one more thing. You can't charge, you can't implicate, you can't arrest a white man. Now, immediately, everyone in the room should think, okay, but what if a white man did it, right? See, don't miss this, before even looking at the evidence, a possible conclusion is excluded, okay? That's what's going on in the scientific community. In fact, when you hear things like intelligent design isn't science, I can almost guarantee you this is what's happening. They're saying, oh, you're going towards a supernatural conclusion, therefore it's excluded, okay? Therefore, that's not allowed. Only natural explanations are allowed. Let me prove it to you. Richard Lewontin is probably one of the most academically famous scientists out there. He's Harvard geneticist, okay? And this is what he said in a book review. He said, our willingness to accept scientific claims that are against common sense is the key to an understanding of the real struggle between science and the supernatural. We take the side of science in spite of the patent absurdity of some of its constructs. In spite of its failure to fulfill many of its extravagant promises of health and life. In spite of the tolerance of the scientific community for unsubstantiated just so stories, because we have a prior commitment, a commitment to materialism. In fact, it goes on to say, moreover, that materialism is absolute, for we cannot allow a divine foot in the door. So we're going to exclude that divine being no matter what. No matter what. Does that sound like objective scientists searching for truth at all costs? Absolutely not. Absolutely not. And so, remember I said most of the time when we study the natural world, we come to natural conclusions. And many people think, well, since we do most of the time, we probably will for all causes, all explanations will be described naturally. And so as science slowly advances, the supernatural explanations are going to decrease, and the natural explanations, they're going to increase. And so, years ago, superstitious people thought that lightning came from the lightning god Zeus. But now we know it's an electrical discharge. You see? We don't need the supernatural to explain lightning. Similarly, things like the cell and other arguments that have been offered up, we'll explain those naturally as well. And so this relegates the idea of God to what they call a God of the gaps. Wherever you find a gap in your knowledge, man, we don't know how that works. We didn't know how lightning worked. Let's just say God did it, okay? That's the God of the gaps. It's an argument from ignorance. Insert God when you don't know something. And over time, these gaps get closed. This is the claim. They get closed until we explain everything naturally. Everything naturally. But is that what's really going on? When we offer arguments for intelligent design, is it just a God of the gaps? I would say no. I think that we actually have a positive case, positive arguments. It's not arguments from what we don't know, it's from what we do know. And I'm going to show you some of that in a minute. In fact, the most exciting scientific discoveries of the 20th and 21st centuries have huge positive theological implications. Okay, I want to give you two. One is the argument for a creator, and the other one is an argument for a designer. Okay, let's go with the creator first. This is an argument from the evidence of the origin of the universe. For centuries, it was believed by most atheists that the universe is eternal and uncaused. However, Christians, on the other hand, have always affirmed the very first verse in Genesis, in the beginning God created. Okay? And up to the start of the 20th century, no one could decide which was true just based on scientific evidence alone. There was some philosophical arguments, but nothing from science. However, that all changed in the early part of the 20th century with that dude. You guys know who that is, right? Albert Einstein, a German theoretical physicist. He developed his mathematical equations for the general theory of relativity in 1915. And then in 1917, he applied them to the universe. And what he found was that equation says the universe is either expanding or contracting. And Einstein didn't like that. In fact, this irritated him. So you know what he did? He inserted what they call a fudge factor. That's the cosmological constant. And it kept the universe static. See, if it was expanding, that means it had a beginning, and a beginning implied a beginner. And he didn't like that. And so I had to put this in. So here's Einstein. Great hair, right? And then here's my daughter. And I think there could be an argument that's made that by the hair, if that points you in, she's going to be a future theoretical physicist. I just know it. I just know it. And so Einstein actually, in 1929, Einstein went to the Mount Wilson Observatory where he looked through a 100-inch telescope. And what he saw actually confirmed the universe is indeed expanding. I want to show you what he saw. He saw that the galaxies were red-shifted. Red-shifted. What does that mean? Well, if a galaxy is moving away from us, in fact, all the galaxies were moving away, they would be red-shifted, okay? If they're moving towards us, we would find that they're blue-shifted. And how do I come to that conclusion? Well, different colors of light have different wavelengths, okay? And so red has a big wavelength, a long wavelength, and blue light has a short wavelength, okay? So different colors have different wavelengths. And so as a galaxy, if it's moving away from us and the rays and the light rays are being stretched out, actually as space itself is being stretched out, this concluded that it was indeed moving away. If they were being compressed, it would have been blue shifted. That would mean that it was probably collapsing. You guys all recognize this as the Doppler effect, even if you didn't know what the Doppler effect is. If you've been to a racetrack or you've seen a car drive past you, you'll notice it does this. You guys want to hear that again in slow motion? I know you do. The waves are being compressed as they come towards the observer. That's like blue shifted. And then the waves get stretched out as it passes. Okay? And the same thing happens with light as it does with sound. And so what ended up happening was scientists concluded that indeed the universe must be being stretched out, expanded, okay, over time. And Einstein knew that even back in 1917. And but if you play this back, like yesterday and the day before and the year before and so on, the universe gets smaller and smaller, and to the point where you get to a beginning of the universe. In fact, you get to a point where there's no matter, there's no energy, there's no time, and there's no space. This indeed is the beginning of the universe. So this was the first argument for an origin of the universe. The second is from the most established law in physics. It's called the second law of thermodynamics, okay? And the second law of thermodynamics essentially teaches that everything is running down. It's heading towards disorder or increased entropy. You can think of it like a car running out of gas, okay? A car running out of gas. In the same way, though, our universe is running out of gas or usable energy. There is a difference between a car and the universe, though. A car is an open system. So when it runs out of gas, you just go to the gas station and fill it up again, right? But our universe is not like that. If it is indeed a closed system, when it runs out of usable energy, that's it. In fact, scientists have a theory called the heat death of the universe. Essentially, molecular motion will cease as the universe ages. And so the question is, well, here's a take-home message. If we went into the parking lot and we found a car running in the parking lot, okay, you would know it hadn't been running from eternity past. Why? Because it would have run out of gas by now. In fact, I mean, this will make your head spin. It would have actually run out of gas an eternity ago if the universe was indeed infinite in its existence. And so the fact that there's gas in the car, that the car's running, shows it was filled up a finite time ago. In the same way, the fact that our universe that we observe right now has usable energy shows that it was filled up a finite time ago. It had a beginning. And so here's the question. We know the effect is the universe. What kind of cause could produce the effect in question? What kind of cause could produce time and space and matter and energy? The cause must be timeless and spaceless and immaterial and so on. In fact, these are the attributes. Without even opening your Bible, these are the attributes we give to God, okay? These are the divine attributes. And so this would be a first argument pointing towards a creator. What could cause the universe to come from nothing? Here are your options. Nothing caused the universe to come from nothing, okay? Or something caused the universe to come from nothing. The smart money is on something, okay? And not just something, but someone. All right, evidence number 2, and this one's a little bit more fun. This is for the design of the universe. The design of the universe. Sometimes we call it the fine-tuning of the universe. I want you to, again, think of a tightrope, but this time stretched across 2 skyscrapers, okay? And on either side of the tightrope, if you were walking across, we would say literally, on either side, it does not support life. Literally, right? If you take one step to the right or one step to the left, you plummet to your death. And so only the narrow position on the tightrope will support life. Now listen, the universe and the earth have many conditions that are finely tuned or finely balanced to support life. They have to be just so, and if they're not just so, there can be no life. What I'd like to do is I'd like to start with the earth, and I'd like to go out from the earth and look at our solar system, and then I'd like to go from our solar system out to our galaxy. In fact, I think I might skip over the galaxy for the sake of time. And then from the galaxy, we'll get back into it. We'll go to the structure of the universe, okay? The structure of the universe. How does that sound? That great, eh? You guys are thinking, how much time do we have? We're going on a mission to the outskirts of the universe? Yeah, we're going there. Okay, let's start with the earth. For life to exist on our planet, we need an atmosphere, okay? And not only do we need an atmosphere, we need just the right atmosphere. For instance, Uranus contains deadly gases. Now, when I say that to a grade 9 class, there's usually a few giggles. And I heard Mike Howe. He was giggling over there. Uranus contains deadly gases. It's true. 82% hydrogen, 15% helium, the rest methane. Those are deadly gases. And stinky, actually. It's the wrong atmosphere. It's the wrong atmosphere. Yet the Earth has just the right atmosphere, in part because it contains oxygen. Okay? It contains oxygen. Our atmosphere is 21% oxygen. And you're thinking, well, what's so special about that? Well, if it was a little bit lower, let's take it down to 15%, everyone in this room would suffocate. We would all drop dead. Okay? So 15%, that's not good. What if we cranked it up to like 25%? You're thinking, well, that would be good, right? More oxygen. Well, 25% oxygen, fires could spontaneously break out with just a spark, making life highly improbable. But I see that none of you are impressed by that. As we all just take a deep breath, right? Oh yeah, that's good stuff. How many of you have heard of Goldilocks and the Three Bears? Everybody, right? Did you guys realize that it's the only children's book that condones breaking and entering? You read that stuff to your kids? Come on. All right, so there's something in astronomy actually called the Goldilocks principle. You know the story, too hot, too cold, just right. Well, in a similar way, our Earth is at just the right distance from our planetary star, which we call the... Very good. You guys didn't know there was going to be a quiz. And so, you see, if the Earth was a little bit closer to the sun, it would be too hot. Venus is a little bit closer, and the surface temperature is around 700 degrees Fahrenheit, okay? So it's kind of warm there. If you go a little bit further out, where Mars is, it's pretty cold there, okay? The average temperature at the surface is right around freezing, okay, even at the equator. And so where we reside that makes life possible is called the habitable zone or life zone, okay? That's where you want to be. That's where you want to be. But not only is that distance finely tuned for temperature, it's also finely tuned for having all three states or forms of water, okay? So if you go to Mars, it's cold. We've actually found ice on Mars, and they're really excited because ice, they might find water, and then, life is just add water, and it's just, there's life. Actually, it doesn't work like that. You need more than just water. And so they've got ice. You go to Venus, and Venus actually has a huge water vapor problem, okay? And that's why it's so hot. It's a runaway greenhouse effect. And so the water vapor in its atmosphere traps the heat, just like a greenhouse does. But if you've been to Earth, how many of you have been to Earth? We have actually all three states of water: solid, liquid, and gas. Now, I really like this picture. Do you guys like that picture? It's kind of cool. The reason I like that picture is for a couple reasons. But before I get there, not only do we need water, we need an abundant supply of water, and our Earth actually has that, 70% covered in water, and more water underneath the crust. We need an active water cycle, and our Earth has that as well. But what's really cool about water, that makes it unique and different from every other substance that we know of, natural substance we know of, is that when water freezes, does it get more dense or less dense? You guys don't know. The grade 9s are thinking, man, in particle theory, something freezes, it gets more dense, doesn't it? Water is the only substance that freezes, and because of its molecular structure, it gets less dense. And that is why that huge iceberg is floating. Okay, you can try this at home. Take a glass of water and pour some ice cubes in it. If the ice doesn't float, you did something wrong. Okay? So this is what would happen. If water was like every other substance known to man, then these guys would sink to the bottom of lakes and oceans, and they would freeze from the bottom up, killing all marine life and eventually killing all of life, okay? And scientists sometimes call this a snowball Earth, okay? So thank God for the way he made water, because if he didn't, we wouldn't be here. The size of the earth is finely tuned. You're thinking, I've talked to some atheists who've said, man, we're so overpopulated. That's not true, by the way. This planet is so overpopulated. God, he could have made it so much bigger. Yeah, let's assume he made it twice as big. And then it has twice the gravitational pull, pulling in greater atmospheric pressure, and then you end up with a planet like Venus that has a runaway greenhouse effect, okay? So you don't want to go there. What if we made it smaller? I don't know why anyone would want to, but if you made it smaller, half the size, scientists say that it would lose its atmosphere and become like the moon, okay, which has no atmosphere. And so it seems like our Earth has just the right size. But not only that, wait, there's more. Did you guys know the Earth is tilted? You probably felt it when you walked in, right? No, you didn't feel it. The reason the Earth is if it wasn't tilted, we wouldn't have seasons. It's partly responsible for why we have seasons. If it wasn't tilted, the equator would be even more extremely hot, and the poles would be extremely cold, making life highly improbable in those regions. But our Earth is tilted at 23.5 degrees, creating the beautiful seasons that we get to experience. But still, you're not impressed. I'm going to impress you with this one. One of the liabilities of being so close to the Earth, remember the Goldilocks zone, the Goldilocks principle, is that our Earth is constantly being bombarded by cosmic radiation, okay? And this is not good, except for the fact that we have a deflective shield that we built. Do you guys hear about the shield that we built that deflects all the cosmic radiation? No, we didn't build one. But our Earth has one. It comes from the giant magnet in the center of in the core of the Earth. Do you guys know there's a bar magnet in the center of our Earth? You guys aren't going to believe anything I tell you. The liquid iron core generates a magnetic field that looks kind of like this. And so when the cosmic radiation comes from the sun, it actually gets deflected. And this is worth the price of admission right here. How much do you guys pay to get in? Let's see that again in slow motion. Yeah. That's cool, right? And so without the magnetic field, life on this planet would be impossible, okay? So thank God for the magnetic field. Now I want to move out to the solar system. Did you guys hear that our solar system only has 8 planets? Did you guys hear about that? Some of the older people in the room are like, no, there's 9, Tim. There's 9. No, you didn't hear about what happened to Pluto. What happened to Pluto? They took it away? Just gone. Somebody just grabbed it and you're out of here. Yeah, it's still there, believe it or not, but Pluto is no longer a planet. Why is that? Does anyone know? I love getting the wrong answers. Someone say it's too small. It's a good guess. What are you going to say? No, it has nothing to do with atmosphere. Who said orbit? You've seen this talk before, haven't you? It's not because it's too small. It's because Pluto shares an orbit with Neptune. What do I mean by shares? It crosses over Neptune, which is its neighbor. It crosses over its orbit. It's highly elliptical. And I don't know who gets to make this call, but somebody said, if you don't have your own orbit, you can't be a planet. Seriously. Who's that guy? I want to be him. Actually, there's debates over this. There's like a 2-hour debate on YouTube that you can watch tonight. It's riveting on whether Pluto should be a planet. Okay, get rid of Pluto. So we got our 8 planets, 4 terrestrial rocky planets and the 4 gas giants. We are the third rock from the sun, but I got bad news for us, because there is an asteroid heading straight for, actually everyone together. Oh no, it's an asteroid heading straight for us. Wow, that was good. We should be giving out Academy Awards for that. Okay, so the asteroid is heading straight for us, or a meteorite, or a comet, or whatever. Now, this would be bad news for us, because a good-sized asteroid impacting the Earth could cause an extinction event that could wipe out all of life. But we're not worried too much about that, and the reason for it is because Jupiter is a cosmic vacuum cleaner. In fact, when I taught grade 9 science, the space unit, that's exactly what the textbook says. They call it a cosmic vacuum cleaner. Here's what happens. Its gravitational field is so strong. I mean, Jupiter, it's not to scale here. You could fit 1,000 Earths inside Jupiter. This red spot on Jupiter is like 2 to 3 times the size of Earth. It's a storm. It's a hurricane that's lasted hundreds of years. Here it comes. Oh yeah, got sucked in there. We should thank God for Jupiter. Honestly, if Jupiter didn't exist, I can guarantee you that none of you would either, okay? None of you would either. And scientists say, well, that's just the way solar systems form. You got these big gas giant planets that act like the offensive line in football protecting the quarterback. That's just how they form. Actually, no. All of the solar planets that we've found, these planets that are orbiting stars that we've seen, and we found over 1,000 of them, in all of those solar systems, we find the big gas giants close to the star, and the terrestrial planets are outside, okay? And so our solar system seems to be the anomaly. In fact, the gas giant planets are closer than Mercury is to the sun, and Mercury is the closest of the planets there. Okay, now forget everything I just told you. You're thinking, that's easy, already done, right? What is he talking about? The case for fine-tuning is really in what I'm about to tell you, okay? And it comes out of 20th and 21st century science, discovering that the constants and quantities in nature are finely tuned for life. And not just our life, I'm talking about life of any kind. I want you to imagine there's a room in our universe, and it controls everything. Let's call it the universe control room, okay? And it has these dials that must be set just right, and if you start messing with the dials, you destroy the universe, right? Now, there's lots of these dials. I'm just going to talk about 3 of them, I think. Listen, if you just take one of these, alter it slightly, you go from life permitting to right next to it, life prohibiting, all right? And when I say there's no life, I mean no galaxies, no stars, no planets, that kind of thing. No chemistry in many cases. Let's look at a few of these. The first is the gravitational constant. You guys have all heard of gravity, right? It's like, huh? What's gravity? It's what's keeping us like in our seats. Every 2 objects in the universe are attracted to each other, okay? So I'm attracted to the podium. I'm attracted to the Andromeda galaxy 2.5 million light years away. Every 2 objects are attracted to each other. In fact, I've probably told you this, but this is a pickup line I used on my wife. In the library at York University, the science library, Stacy saw me and she couldn't resist. That's a true story. And so anyways, we were introduced. A friend of a friend kind of got us chatting with each other, and I said, "Did you know that you're attracted to me?" And she's like, "Excuse me?" And I said, "Well, gravitationally, right? Every 2 objects. It's a physical attraction, people." And so anyways, the gravitational constant that's in this equation right here that every grade 12 high school student should learn if they take physics. the gravitational constant is finely tuned to at least 1 part in 10 to the 40th power. Some say even greater. I'm going to be real conservative here. 1 part in 10 to the 40th power, okay? What does that mean? That's a 1 followed by 40 zeros. Just to give you a sense of that, how big that number is, actually how small the number is, it's a fraction. The odds of being hit by lightning are about 1 in a million. The odds of winning the lottery in Canada, I'm rounding up here, 1 in 100 million. The odds of being struck by lightning twice are 1 in a trillion. And our number for the gravitational constant is with all the white zeros. Let me try and put this in perspective for you. Imagine we take the entire continent of North America and we cover it in dimes. Covered in dimes. Oh, there we go. All dimes. And then we say that's a lot of dimes. That's a lot of dimes. And then we stack them up to the moon. Okay? And I gave up here. I only did some of it. Say, that's a lot of dimes. And then we do that on 1 billion more continents the size of North America. Okay, now say, that's a lot of dimes. Okay. And then I paint one of the dimes red, and then I blindfold Mike and say, pick the red one out of all the dimes or you're dead. That's the chances of getting the life-permitting gravitational constant. You guys, you what? That's right. You died in the last illustration. Can you see how actually the chances of you picking the red dime are actually better than getting the gravitational constant 1 part in 10 to the 40th power? If he picked the red dime, no one in this room would say, man, you're really lucky. You'd say, Mike, you peaked. You cheated. You designed the outcome. Okay, maybe that illustration doesn't float your boat. Here's another one. If we took a tape measure and we stretched it across the entire visible universe, okay, that's a big tape measure, across the entire visible universe, and it's in 1-inch increments, and one of the inches at one point, just one, is the life-permitting inch, okay? If you go to the, which way are we going to go? If you increase the gravitational constant, just move it over 1 inch, the universe just collapsed in on itself. Big crunch. No universe. If you take it the other way, let's make the gravitational constant a little bit weaker. Let's just move 1 inch the other way. Then the universe blows apart and you never get galaxies and stars and planets. Just gas. Just hydrogen. Okay? This is the fine-tuning we're talking about. And that's nothing. The gravitational constant is a joke compared to the real fine-tuning. Things like the cosmological constant. 1 part in 10 to the 120th power. And by the way, these numbers aren't numbers that us creationists are sitting around calculating. These are numbers coming from even atheistic scientists, okay? And so they would agree with this. By the way, there's only 10 to the 80th power particles, subatomic particles in the universe. That's the orange there. And so you're not getting that by chance, okay? You're not getting that by chance. And if that doesn't work for you, how about this one? This is the mother of all fine-tuning. The mother of all fine-tuning, calculated by Roger Penrose, a mathematical physicist at Oxford University. And he says the initial mass energy distribution. I wish I had 20 minutes to talk about this with you. But he says the original mass energy distribution of the universe that exists at the creation event so that years later you can get a life-permitting universe is finely tuned to 10 to the 10 to the 123rd power. That's a hyper-exponential. Looking at that makes me throw up a little in my mouth, okay? Seriously. You'll never see a hyper-exponential again. You put that in your calculator, it will melt, okay? It will melt. And that's why non-Christian scientists, like theoretical physicist Freeman Dyson, who also invented the vacuum cleaner. No, he didn't really. He's a little busy doing whatever theoretical physicists do. He says this: the more I examine the universe and study the details of its architecture, the more evidence I find that the universe in some sense must have known we were coming. Remember the God of the gaps? No. As he studies the details, the more evidence he finds. The universe in some sense must have known that we were coming. Here's George Greenstein. He has a PhD from Yale, and he's a professor of astronomy. He says, as we survey all the evidence, the thought insistently arises that some supernatural agency, or rather, capital A agency, must be involved. Is it possible that suddenly, without intending to, we have stumbled upon scientific proof for the existence of a supreme being? The answer is yes. Was it God who stepped in and so providentially crafted the cosmos for our benefit? And I would answer yes again. Robert Jastrow was an agnostic astronomer, and he said this: for the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He has scaled the mountains of ignorance. He's about to conquer the highest peak. And as he pulls himself over the final rock, he is greeted by a band of theologians who have been sitting there for centuries. Because what have theologians been saying for centuries? I don't know. Things like, in the beginning, God created the heavens and the earth. Right? Some of these theoretical physicists are starting to get caught up with all this stuff. So, where have we gone in this session? I think we've shown that a biblical understanding of faith is perfectly compatible with science. In fact, there are a number of places where good science points towards a creator and a designer. We just looked at a couple of them, and we could have gone on and on each, and in other arguments from biology in particular. It's no wonder that the Apostle Paul says this about those who reject the evidence of a creator. Okay, he says they're without excuse. Romans 1:20. For since the creation of the world, his invisible attributes, his eternal power and divine nature have been clearly seen, being understood from what has been made, so that they are without excuse. Many people think that they can hide behind science to avoid God. I talk to lots of these people. I believe in science, Tim. I don't need any of that faith stuff. They think they can hide behind science to avoid God. The problem is a good study of the natural world reveals that God's fingerprints are all over this thing. They're all over it. And so they are truly without excuse.